Greetings one and all, and welcome to this math video. Today we're going to be considering a question on vectors. And notice what we have in front of us. It says four vectors are given in component form. So we have these four vectors. We have the vector p, which equals to 2i minus 3j. We have the vector q, which equals 3i minus 2j. We have the vector r, which equals 4i minus 6j. And we have the vector s, which equals negative 2i plus 3j. And these vectors are given in component form. Now, some of you may be more familiar with writing vectors not in component form, but in column form, or the column representation of a vector. And so let's do that. Let's write these vectors, which are written in component form. Let's translate them into column form. And so we have 2 and negative 3. So this is the vector p written as a column vector. And we have the vector q. And written as a column vector, the vector q would be 3 on top, and of course, the negative 2 at the bottom. And then we have the vector r. And written as a column vector, the vector r is 4 on top and negative 6 at the bottom. And we have the vector s. The vector s, written as a column vector, is negative 2 on top and 3 at the bottom. So we have these four vectors. We have them in component form, and we have them in component form, and we also have them in written as column vectors or column form. So they're saying, look at these vectors. And from looking at these vectors, we want you to list a pair of vectors that are parallel and of the same magnitude, that are parallel but don't have the same magnitude, and that have the same magnitude but are not parallel. And that's what our task is. Now, if you look at each of these questions, right, each of them have the word parallel. So we have this one of parallel, this one of parallel, and the third one has parallel as well. So the question is, what are parallel vectors? How do we know if two vectors are parallel? So first, let's recall what is meant by parallel vectors. So if we have two vectors, let's call one A and let's call the other one B. So we have the vectors AB. Now, if these two vectors are parallel, then that means that there must exist a number. And we're going to call that number n. Now, we don't know what n is, right? N could be 1, n could be negative 1, n could be 2, n could be 3. But n must be a number. So if A and B are parallel, then we know that we can find, or there exists a number, and we call it n because we don't know what it is, a number n such that I can take this n, right, multiply it by one vector, and that will equal to the other vector. So if two vectors are parallel, then that means that there is a number that I could use to multiply by one vector to get the other vector. Now, if the vectors A and B are parallel, then that means that they are scalar multiples of each other. And if they are scalar multiples of each other, then that means that they are parallel. So with that in mind, let us proceed with the question. So we're looking from these four vectors that we are given, P, Q, and R, and S. We are looking for the vectors that are parallel and have the same magnitude. Now, note that let's consider P, right? Let's consider this vector P, right? So we have this vector P, and let's consider the vector S. Are they parallel to each other, and do they have the same magnitude? Note that let's take a consideration at P, right? Note that P, we could write P in this way, right? You say, Isaac, what do you mean? How can we write P in this way? Notice that negative 1, let's do it. Negative 1 multiplied by negative 2i equals 2i, because the negative and the negative becomes a positive. So we have the 2i here. So negative 1 multiplied by negative 2i is 2i. Great. What about negative 1 multiplied by positive 3i? Well, that is negative 3i. Sorry. What about negative 1 multiplied by positive 3j? What is that? Negative 1 multiplied by positive 3j. Well, negative 1 multiplied by positive 3j is negative 3j. So therefore, P can be written in the following way. P can be written as negative 1 multiplied by this vector here. But what is this vector? What is the vector negative 2i plus 3j? What is this vector? Look carefully. What is this vector? Well, this vector is exactly S, because notice that we have negative 2i, and we have negative 2i here, and we have positive 3j, which is positive 3j. So that means we can, instead of writing this negative 2i plus 3j, we can simply write the vector S. So that means that P equals negative 1 S. So let's write that, right? So that means that P, the vector P, equals negative 1 S. So the vector P equals negative 1 times S. So what can we say about this, right? We can say since P equals to negative 1 times S, that means that the vectors P and Q, sorry, that means that the vectors P and S, not P and Q, the vectors P and S are parallel. And why do we say that? Because remember what it means to be parallel. Notice that we have a number. And what is that number? Negative 1. That we can use to multiply by S to give us P. Look at that. We have a number, negative 1, that we can use to multiply by S to give us P. And so therefore, the vectors P and S are parallel to each other. So they are parallel. But we want more than just being parallel. Do they have the same magnitude? Now, in order to calculate the magnitude, so this is the symbol that we use for the magnitude of P. In order to calculate the magnitude of P, we have to take its first, the coefficient of I, so we take 2, and we have to square it. So we have 2 squared, and we have to take negative 3, and we have to square negative 3, so that's negative 3 squared. Now what is 2 squared? Well, 2 squared is 4. And what is negative 3 squared? Well, negative 3 squared is indeed 9. Because that's simply negative 3 times negative 3. And negative 3 times negative 3 is positive 9. Now what is 9 plus 4? Well, that's 9, 10, 11, 12, 13. So that equals to 13. So the magnitude of P is equal to the square root of 13. Well, what is the magnitude of S? Well, the magnitude of S, let's calculate it. We take the first, we look at the first term and we consider its coefficient, the coefficient of I, and that is negative 2, and we square it. And we take negative 3 and we square negative 3 because we have, it's supposed to be positive 3 here. It's supposed to be positive 3 because we have a positive 3 here. It's not supposed to be negative. It's supposed to be a positive 3. Good. So we have positive 3, right? Positive 3 squared. So what is negative 2 squared? Well, negative 2 squared is indeed 4. And what is positive 3 squared? A positive 3 squared is still 9 because 3 times 3 is still 9. So we have 9 plus 4, which is 13. So we have the magnitude of S is equal to the square root of 13. So that means both of these vectors have the same magnitude. Thus, the two vectors have the same magnitude. All in all, the vectors P and, not Q, but P and S are what? They're parallel, like we saw in the first one, in the first point, they're parallel, and they have the same magnitude. So it fulfills our criteria. So the vectors that we're looking for this particular answer is the vector P and the vector and the vector and the vector S. So P and S fulfills this criteria. Now let's move on to the next question. Here we want two vectors that are parallel but do not have the same magnitude. Parallel but do not have the same magnitude. So let's look back at our four vectors that we have, and we want to find two vectors that are parallel, but they must not have the same magnitude. Let us consider R. So we look at R. R is 4I minus 6j, and we can write R, the vector R, in a different way, right? Still meaning the same thing, but we can express it in a different way. Notice that we can factor out. Notice we have 4 and 6. And a common factor between 4 and 6 is 2. So we could factor out a 2. All right. And if we factor out the 2, this will be 2 times 2i, which is still 4i. And we have 2 times negative 3j, which is still 2 times negative 3j, which is still negative 6j. And so this expression here is the exact same thing. So R can be written as 2 times another vector. Now, what is this vector? Look carefully. What is this vector? What is 2i minus 3j? What is that? Well, 2i minus 3j, that is exactly the vector p, right? P is 2i minus 3j. So instead of writing 2i minus 3j, let us just write p. So that means that R equals to 2p. And that's what we have. R equals to 2p. Now, so what does this mean? What does this tell us? Well, we have found a number that we can use to multiply by one vector to get the other vector. And therefore, that means that the vectors R and P are parallel. The vectors R and P are parallel. We know also by this equation that R is 2 times P, which means that R is going to be twice as long as P, all right? And so since R, so let's say for example, R was represented like this. Sorry, let's say for example, my apologies. Let's say for example, P, right? Let's say for example, the vector P, let's use baby blue, was represented like this, right? Let's say this was the vector P. Now, R, remember R is twice as long as P. R is twice as long as P. So that means if P is that one in baby blue, then R is going to be 2 times that. So it's going to be here, and it's going to go another here. So this would be R. So my question to you is, do these two vectors have the same size? Do they have the same magnitude, right? Do they have the same size, or do they have the same magnitude? And the answer is no. Of course they do not have the same magnitude. Remember, magnitude means size or length. So these two vectors, vectors P and Q, do not have the same magnitude because clearly R is longer, I should say, than P. In fact, R is 2 times as long as P. So, so the vectors R and P, yes, they are parallel, but they do not have the same magnitude or length. So here the vector R is twice as long as the vector P. So that means that they don't have the same magnitude. So it fulfills our criteria. They are parallel, but they do not have the same magnitude. So the vectors that we're looking for this particular question is the vector R and the vector P. So the vector R and the vector P fulfills this criteria. Now let's move to our last criteria. What we need is we need two vectors that have the same magnitude. They have the same magnitude, or they have the same length, or they have the same size, but they're not parallel. So let's look at our vectors, our four vectors here, written in component form. Let's look at them. We have P, Q, R, and S. And we want to know which two of these they have the same magnitude but not parallel. Let's see. Let's consider the vector P, and let's consider the vector Q. Let's look. we see the vector p is 2I minus 3j. And so if we were to take the magnitude of p, the magnitude of p is, we take 2 and we square it, and we take negative 3 and we square it. And so 2 squared is 4, and negative 3 squared is 9. And so what is 9 plus 4? Well, 9 plus 4 is indeed 13. We saw this already, the square root of 13. So the magnitude of q is indeed the square root of 13. Now, what is the magnitude of q? In order to find the magnitude of q, we must take 3 and square it. We must take negative 2 and square it. And so let's consider that, right? Let's consider that. What is 3 squared? Well, 3 squared is 9. And what is negative 2 squared? Well, negative 2 squared is indeed 4. And so we must add these. And so what is 9 plus 4? Well, 9 plus 4 is again 13. And so we have that the magnitude of q is actually equal to the square root of 13. So the magnitude of p and the magnitude of q are identical. They're the same. So they have the same magnitude, right? They have the same magnitude. But the question is, are these two vectors parallel to each other, right? Are these two vectors parallel to each other? Let's look at these vectors, 2I minus 3j and 3I minus 2j, right? Is it possible for me to find a number, a real number, that I can use to multiply by one of these vectors to get the other vectors? And the answer is no. There is no number that we could use to multiply by one vector to get the other vector. So they are not scalar multiples of each other. These two vectors are not scalar multiples of each other. Therefore, they are not parallel to each other. And so they have the same magnitude, but they do not have, but they are not parallel. We can't find a real number that we can use to multiply by one to get the other one. And so the vectors that we're looking for this particular one is the vectors p and q. P and Q. All right, so that brings us to the end of this particular video. Thank you for your time and attention, and I'll see you in the next video.